Determine whether the following equation is exact. If it is exact, find the solution. So we have an equation in this form: m dx plus n dy equals 0, and we know this is exact when my, partial derivative of m with respect to y, equals nx. Okay, so let's check if this is exact. So here m as a function of xy, this is m, this is n. 2xy squared plus 2y, n xy is 2x squared y plus 2x. Now we want to find the partial derivative of m with respect to y. So with respect to y, 2x counts as constant, and derivative of y squared is 2y. So 2y 2x, so 4xy plus derivative of 2y is just 2. Now let's find the derivative of n with respect to x. So y counts as constant, so 2 to 4xy plus derivative of 2x is 2, and my is same as nx, they are same. That means this ordinary differential equation is exact. The equation, okay, equation is exact. Then by definition, now we move to the next step here. Then by definition, there exists a function f such that fx equals m and fy equals n. Then there exists a function f that's to be determined. F is a function of xy such that partial derivative of f with respect to x will be m, that's 2xy squared plus 2y, and partial derivative of f with respect to y is 2x squared y plus 2x. Now with the help of these two, we are supposed to recover the function f back. Then f, this function f equals c, is the general solution. Okay, so this is the partial derivative of f with respect to x. Let me write this as 1 and 2. Let's integrate 1 with respect to x. Equivalently, we can integrate 2 with respect to y. It doesn't matter. I generally pick the easier function. In this case, both functions are about the same, so I'll pick 1. Integrate 1 with respect to x, we get, so we have partial derivative of f with respect to x dx equals 2xy squared plus 2y dx. And in this case, y, the variable y, behaves as a constant, and partial derivative of f(x) is just f as a function of xy, by the way, equals, now let's integrate, y squared is constant, antiderivative of 2x is x squared, so this is x squared y squared plus 2y is constant because we are integrating with respect to x. Antiderivative of 2y constant times 1, so antiderivative of 1 is just x plus some constant of integration. In this case, since y is also a constant, we can have a function of y or just a pure constant, so I would write hy. Okay, let's say this is 3 where hy is the constant of integration, because y is constant in our case. So this hy, this could be a pure number or a function of y. Now look at number 2. Equation 2 is the partial derivative of f with respect to y. So let's find the partial derivative of f in 3 with respect to y and compare with 2. Okay, then partial derivative of f with respect to y, that's from 3, and we'll compare this with 2. Partial derivative of this function with respect to y, so x square is constant, derivative of y square is 2y, so 2x square y, plus x is constant, derivative of 2y is just 2, so 2x, plus now this is a pure function of y or just a constant, and we are differentiating with respect to y. Derivative with respect to y will be just the regular derivative, h prime y, that's 4. Okay, now we compare 2 with 4 because we have fy. In that way we can find the value of h, and our answer is the function f equals c, and f is given in number 3, but we need to determine hy. That was missing. Now compare 2 and 4 to get, let's see, in 2 and 4 the left hand sides are equal, fy, so 2x square y, 2x square y, they are same, and here is 2x same. That means this h prime y should be 0, okay, because there is nothing here, but the left hand sides are equal. That means h prime y must be 0. Now we find the value of h. In this case, integrate with respect to y, just the regular derivative, so integrate, then this implies the h function should be, look, the derivative of h is 0, that means this should be a constant, just a constant, let's say c or c1, because the derivative of constant is 0. In fact, this h we chose in equation 3 was a real number, just a constant. Thus the final answer, the solution is fxy equals some constant, we can say c1, c1 is used, c2 or c, where f is given by 3, so here's 3, okay, here's function, so x is square y is square plus 2yx, which is same as 2xy, plus hy, h was found c1, plus c1 equals c2, and we can always move c1 to the other side, and c2 minus c1 just a constant, that is x is square y is squared plus 2xy equals c2 minus c1 c, and this is the final answer.